Okay, so following on from the previous video clip, Cox Ross Rubinstein from Leisen Reimer C++ Volopta. We set up this the code from Volopta in Visual Studio 2015, and I'm taking the same code this time. So it's from Fabrice Roy and it's from Volopta. And we're going to copy this code, which we amended slightly to reflect the implementation of a Cox Ross Rubinstein binomial tree. So we've copied this and we go into Xcode. So Xcode, and create a new Xcode project. And so it's OSX application command line tool next, and it's CRR from Leisen Reimer, and it's Volopta, and hit next. And then we just create on the desktop. Well, we can create here. In the documents folder, we come to main. We take out this code and we paste. And so basically the code we had before, we can remove some code where there's a little bit of difficulty. This code was originally taken from Volopta to estimate Reiser Reimer Reisem, and we don't actually need it here, so I can take it out, and so that's removed. So most those issues are resolved. We put in parameter inputs for estimating the value of an option, 100 spot, 100 exercise, time period 1 year, risk-free rate 5%, and volatility 20%. We don't need the if statement here, so we don't actually need to convert to an odd number. We also don't need the method in this instance, so we can put the / twice, and that neutralizes that element of code. And D, is there an issue with D? I don't think so. Okay, so let's run this code. And it's 1,000 steps, so the build succeeded. Okay, and I need to put in password. And we get our output. Okay, so 1044.86. Now the true value for the European code using those parameter values would be 1045. Let's run it again and put in an extra. Let's put in 10,000. On the Visual Studio 2015 it crashed, but I was in a parallel Windows on another Mac. Okay, so we got the output. Let's try a higher number of iterations, a higher number of steps in the tree, and we can run this again, and it may take a minute, so I'll pause. Build succeeded, and about a minute, maybe 2 minutes after it has passed, and the code is converged, and you can see that the value we're getting for these parameter inputs is for the European code is closely reflecting 1045 Interestingly, if you use Leisen Reimer code, this should converge at about 100 steps. So that's a substantial saving in computational processing. Okay, so that's Cox Ross Rubinstein generated in using code from Volopta, right? And we've adopted Fabrice's Leisen Reimer code to set up a Cox Ross Rubinstein tree, which is a little bit less efficient. Okay,